Hi, my name is Inosh, and today we are going to talk about SOLID principles. SOLID is an acronym that stands for 5 basic principles of object-oriented programming and designed to fix stupid code. SOLID stands for Single Responsibility Principle, Open-Close Principle, Liskov Substitution Principle, Interface Segregation Principle, Dependency Inversion Principle, and STUPID is also an acronym which stands for Singleton, Tight Coupling, Untestability, Premature Optimization, Indescriptive Naming, Duplication. We'll see stupid in some another video. Today we are going to talk about only about solid principles. So the first principle is Single Responsibility Principle. It states that every class should have a single responsibility. There should never be more than one reason for a class to change. For example, if we think about a driver class, it has only responsibility to drive. If the driver class also handles telephone calls or make telephone calls, then you know what will happen. Second is open-closed principle. It states software entities should be open for extension but closed for modification. To put this more constructively, you should write a class that does what it needs to do flawlessly and not assuming that people should come in and change it later. So for that, you should make all member variables private by default. Write getters and setters only when you need them. For example, when you purchase your mobile phone, you get the entire package. That is, the hardware consists of a display, some speakers, cameras, etc. And software consists of the operating system. Now this is a closed principle. So you will also get this Apple Store or Google Play, and using this you can extend the functionality of your mobile phone by downloading apps. So now you cannot make any changes in your operating system, but you can extend the functionality of your mobile by downloading these apps. Third is Liskov's substitution principle. It states that subtypes must be substitutable for their base types. Basically, instead of using actual implementation, you should always be able to use base classes and get the result you were waiting for. There is a parent class as animal, which makes noise, and child class as cat, which also makes noise, dog, which makes noise, but there is a mute mouse, which actually doesn't make noise but throws an exception. So Liskov's principle says that there cannot be a mute mouse which actually doesn't make any noise. Fourth is interface segregation principle. It states that many client-specific interfaces are better than the one general purpose interface. In other words, you should not have to implement methods that you don't use. Enforcing interface segregation principle gives you low coupling and high cohesion. Imagine your code consuming some big fat interface and having to recompile or deploy with annoying frequency because some method you don't even care about got a new signature. So, for example, think about a restaurant. It has a main menu which has some fixed items, but there is soup of the day which keeps on changing every day. Clients that don't care about the soup need not even be concerned, and clients that use a different interface ask the server. Last is dependency inversion principle. It has two key points. Abstraction should not depend upon details, and details should depend upon abstraction. According to this principle, the way of designing a class structure is to start from higher level modules to the lower level modules. Higher level classes, then abstraction layer, then lower level classes. Intent: higher level modules should not depend on lower level modules. Both should depend on abstraction. Abstractions should not depend on details. Details should depend on abstraction. For example, when you go to your local grocery store, when you purchase your items, you give your credit card or debit card to the shopkeeper. Without any knowledge, the shopkeeper swipes the card and the transaction goes through. So both you and the client depend on the credit card or debit card's abstraction without worrying about specifics. Now keep here in mind, dependency inversion principle is not the same as dependency injection. So these are solid principles. Thank you for watching. See you in the next video.